Hey guys, this is the third part and the last part of the OOP fundamentals. Let's see what we got. Yeah, we learned that object-oriented paradigm has four fundamental concepts, and we learned them as a pie. So these four guys. So all of these gray guys are already covered. So today we are gonna talk about the polymorphism, which is one of the most important ones. Okay, before I start, let me give you a warning. So to understand this lecture, you need to follow me by your IDE. So bring up your IDE and from time to time pause the video and think about that. So what happened and why it happened? All right. So you need to follow step by step whatever I am doing in my live demos. So if you just watch the video and even if you take some notes is not enough, I believe, right? All right, let's get started. Polymorphism. So what is polymorphism? So I believe that polymorphism is a masterpiece of the OOP. So it is the crown of the those four concepts that I talked about. So before we learned that OOP can cope with two software engineering phenomena that are change and complexity. What does it mean? It means that over the time your software will change non-stoply. It is changing, right? And when it change, you are increasing the complexity of your software, and a paradigm should be able to cope with this, and we claimed before that the OOP can do that. That's why OOP is still alive. All right. And between those four that I talked so far, polymorphism plays an important role for dealing both of them. All right. All right. So before starting the programming, let me start with some very familiar examples around your, environment. All right. So these are some things that we see, in our day-to-day living. All right. So first example is a vending machine. So in vending machine, there is a slot here that you can put the coins. All right. And there is a digital, probably digital screen uh, that shows that how much coin you inserted. Okay, so when you insert a coin, what would happen? How the machine behaves. So based on the type of that coin, it shows something, right? So just notice that we have one slot for different types of the coin. So, so for example, when you insert, let's say, a quarter, it registers 25 cents. And if you insert a dime, it registers 10 cents. So machine behaves, differently based on the type of the coin you had. Okay, so let me summarize what we got so far. We have the same interface, right? So this is actually the interface of the machine. We have the same interface, but we can, put different coins, or let's say we can insert different objects, and machine behaves appropriately based on the type of the coin. Okay? So the question we can ask, what if we can have different slot for different coins? Then, wasn't it better or easier that we had different slots for different coins? Yeah, probably you are thinking, yeah, maybe that's not a bad idea because behind the scene, the machine needs to recognize what kind of coin it is, right? So we have an extra process behind the scene. So, what would you say? Isn't it better to have different slots for the coins? Ye- I don't think so, because if let's say government introduce a new coin, maybe 2 months later, they introduce a new coin. So this, happens very rarely in the United States, but in other countries, as far as I know, it happens, right? So in that case, then we need to change the interface of all machines, right? So all of the machines should change their interface. But if we have only one slot, and we just even though we need to change the to recognizing the new coin, but it would be much easier, right? All right, so since I don't want to sell vending machine, let's say that, yeah, this is a true statement. All right. Okay, so this is another example, meeting table example. What is that? So let's say we have, in City Hall, a monthly meeting, right? Uh, and let's say that we have such table, and there is a card here for every person who needs to participate in this meeting. So every person, there is a card, and the full name of these people are written on those cards. So let's say, for example, Monica Geller, Rachel Green, Phoebe Buffet, Chandler Bing, and Joey Tribbiani. So these five persons, the names are on the cards here. And I am sure that most of you guys are familiar with these people. Yeah, that's our lovely friends, people. Anyway, so in this configuration, there is no flexibility, right? So every month, all of these persons should attend this meeting. Yeah, Monica Geller. So it should go here, and the rest of them. So there is no flexibility. All right. Now let's make it a little bit more flexible, right? In this scenario, I'm going to remove the first names, and then let's see what would happen. So we remove all of the first name, and we leave the last names or the parents' names, right? So from now on, instead of the Monica Geller, everybody whose name, whose surname or family name is Geller can attend here, right? For example, we can, 1 week, 1 month, we can send Ross Geller. Yeah, again, our lovely friends, guys, right? So What's happening here? So the there there any similarity between whatever we set so right now and the slot of in the vending machine? Do you see any similarity between these? So in that vending machine, we had one slot for several coins, right? And here now we have one parent name. Then, 1 month we might send the, Roskeller. The 1 month we might send, her, let's say, father. Yeah, everybody who has the Geller name, right? So we see that there is some similarity. Yeah, just keep in your mind up to this point, and we will get back to these two examples. I'm gonna explain the polymorphism concept via a simple application. So we try to develop a simple application, and I try to, explain the polymorphism and why the polymorphism is so important. All right. So so yeah, we have several episodes here. So we start from the episode number 1. Let's assume that we are in 1980s and we are going to develop a very simple game for young kids, right? Our game is very simple board. It has just one button and one display, right? So let's say that we have written the cat here, or maybe it's an image of the cat, and when the key push on this, here on display, it shows the meow, or let's say it's play a sounds, right? For simplicity, we just say that, it prints a meow here, all right? Okay, so Uh, yeah, I explained all of this stuff here. So this is our actually in episode 1 is our problem statement. This is whatever we want to do. All right. Okay, so in the episode 2, we try to implement this simple application. But let's say that this is a very complicated, uh, software, and we are gonna hire or make a contract with another company that just produce the printing the voice or playing the sound, in our case just printing the voice name, right? So we want to hire another company. Let's say that that company's name is voice service company, all right? And we will use their product, yeah, as a library to our product. And this is a very good um, experience for you guys, that how we can integrate uh, another libraries inside our code. Okay, let's see what is the code here. All right. I'm going to show you a live demo, but before that, let's look at the code on this slide, and then I will bring up my Eclipse. All right. So the voice service company, the main code is this. All right. And they define the cat class like this. All right. So this main code, let's see what is this. So the class name is cat voice service, and they have this method that has dependency to the cat class, and here is the cat class. So we have an instance variable that is the voice of that cat, and also we have a getter here that return the this value. All right, and let's see how we can create our application. So our application, we assume that we already have this code as a library, and I will show you how we can do that. Then we instantiate this class, this guy here, and then in this method, we are going to instantiate a cat, and we use this reference to call this method. All right, and this method, and by passing the cat here, it goes here, and then here it will call the get voice, which is this guy. Okay, so let me show you online. I mean, in a live demo, and see what would happen. Okay, so this is my Eclipse. Let me create a new package for our company, whatever we have. Uh, let's call it just polymorphism, right? And all right, so inside this code, we are going to create the animal game. So a new class, just call it animal game, right? Okay, so before we can continue on our side, I'm gonna create a new project for that voice services company. Okay, so we pretend that this project is, coming from their company. All right, so here I'm going to a new Java project, and the project name, let's call it the same as their company name, voice services, let's say co, for example. Okay, so we create a new package here. The package name is the same as their company name. It's fine. All right. So what we need from them, look at this code. So first of all, we would need a cat class. So let's go ahead and create a cat class. We call it cat, and everything is fine here. So look at that cat class. We will have a private string voice equal to meow, right? And also we would need a getter for that, as simple as possible. String get voice, and yeah, just here we just return the that instance variable. All right, so this is the cat, and we would need a cat voice service class as well. Okay, cat voice service, and that's enough. Okay, inside here, we would have a simple public void print cat voice, and we are gonna pass the cat here, and just simply let's just print the that. So we are going to call the get voice here. All right, so their code is ready right now. So they need to create a jar file from their code and send it to us. All right. So now let's see how we can create a jar file. Just here, right click here and say export, and just search for the jar, and you will see EJB jar and Java jar. We want Java jar. All right. Next. So there are some setting here. So first of all, what we are going to make a jar. So this will be the this guy, the voice services guy, right? Everything inside here, all right? And also we need to give a place for that. Let me put it somewhere very specific. Um, let's call it here, or maybe inside the WS, which is my workspace. Let me create a, let's call it jars. And yeah, so this voice service animal game jar, it goes to here. All right. Let me see anything else we need to. Yeah, looks like everything is fine. Okay, so the jar file is created now. So the voice services company's job is done. Now we are gonna go here, and in our part, which is here in the polymorphism part. Okay, so this is our animal game, right? Okay, so now let's see how can we implement that. So we would need a cat. Okay, so first we need to import that jar and put it in a build path. Okay, so go ahead and go to the build path configuration, and yeah, actually I put it before. Now let's actually that was the wrong place, and go and add external jar, and it was on dev workspace jars, and this is the right one. All right, apply and close. So now we added those jar file as a library to our code. So now the cat, if we just say cat voice service, call it CVS equal to new uh, cat voice service. So it cannot recognize this, just control one, yeah, import this guy here. Okay, so this guy was imported from the library now. Okay, so look at the code, our application. So we would need a public void call cat voice services, right? And we instantiate a cat here, and the cat should be recognizable because the cat is in the jar file. So uh, yeah, we new cat, and you see, oh, it didn't recognize that. Let's see, import the cat. Yeah, we should import the cat as well. All right. Actually, it depends on how we define that import. If I put here instead of this as is a star, then I didn't have this problem. Anyway, no problem. And yeah, just print, and that's it. So this is our code, and here I just need to pass the cat. All right. So up to this point, our code is working fine, and there is no uh, complaint here in the cat voice service and in the animal and also in their cat. Everything is fine. So up to this point, we see that this is actually the end of the episode 2. Okay, what else we have? Episode 3. Let's say that market demand is high and we are gonna create a new version and we are gonna create a new button and let's call it dog. Okay, so we have a new requirement, right? And we are going to ask them to about our requirements, and they need to upgrade their voice services as well. All right. Okay, so maybe they are thinking that cat voice service, it was their class name. It's too specific to a specific animal. So they are going to change it to animal voice service. That's fine. All right. So let's see how the code is changed. So their code, so first of all, they change it to animal voice service. That's fine. And print cat voice, is the same thing as the previous code. We didn't change. They just need to create a new one for the dog, right? And we know they need to pass the dog instead of the cat for this guy. And here would be the dog class, very similar to the cat class. Okay. And how about our company? Our company, we just need up to this point is the same thing. Yeah. We just need to add a new portion for the dog. So this portion should be, uh, you know, um, added for the dog. All right. So let me create it here and step by step, let's, follow the code. Okay. So let's first refactor the code because they changed their class name to animal voice service. So this cat voice service should be refactored. So we find the refactor and rename, and we call it animal voice service. All right. Okay. So another thing they added is a dog class. So let me copy and paste it here, and let me just call it dog. All right. And the dog class, yeah, the only difference is its voice. The rest of that is the same thing. All right. Okay. Another thing we need to add is just to add one portion of this for printing the dog voice, right? So we call it dog, and instead of cat, we send dog. And here it is just D. All right. So their job is done, right? But since the code is changed and we added some, renamed the classes and we added these dog guys, so we need to create a new jar file. So we go to the voice services and we go to export and the jar file. And what should we bundle here? Yeah, it's correct. So the voice service code, the package, the full package. And let me, yeah, just name it something else. Let's call it this game 2. So this is our second version. And what else? Everything is fine. And I believe everything is fine. Just finish that. Okay. So this jar file is created, and now we need to add it to our company. So we go to the build path again, and this is the old jar file. We should remove that because it's a version 1, so version 2. So we go to the add external jar, and we add it here and apply and close. All right. So yeah, they sold their jar file to us. Now let's see what we need to add in our animal game code. So yeah, this guy is no longer validated. So let me remove this import and let me create this as animal, and we copy and paste it here, and control 1 import animal. Yeah, that's cool. And for this one, import the cat from the voice services. So everything is fine. So the other thing that we need to add here, another method for call dog, right? And we need to change all of these to dog, dog, and print dog voice. And here we just send the dog. All right, the dog cannot be recognized. Control 1, import dog from the voicemail, uh, voice services. All right, so it looks like that we are done here, and there is no complaint in none of the classes that we have. Before going further, we have a new term here. Maybe some of you guys are familiar. So method overloading. So this is a very nice Java feature that we call method overloading, and here is what we can do. So we can have the same name of the methods in one class, but different list of the parameters, right? So since this is the case, then uh, probably the voice service company is thinking that instead of print cat voice, print dog voice, instead of this, just remove this the animal name and just say print voice. And so print voice, but different parameters, right? So this is called overloading, method overloading. All right. Okay, now let's see what we got here. So we would need to change our, their code and our code as well. So the voice services company, animal voice service, right? So this is the print voice for the cat, print voice for the dog, and in our code there won't be, let me see, yeah, we just need to, uh, instead of calling the print cat voice and print dog voice, we need to change our code as well. All right, so yeah, this would be the end of the episode number 3. In episode 4, some brainstorming is happening in the voice services company. Why? Because some of them are thinking that, okay, so for every changes we need to change the code and send the jar file again. Is this the case that our code is, designed very well and it can cope with the change and complexity? They are asking themselves. So, yeah, for every small changes, they need to change the code. All right. So they are asking, what is the bottleneck here? Right. That's a very good question. So the print voice, yeah, XXX something. So This is for the animals, right? In some cases it was with cat, then we added dog. They are, predicting that maybe, in a few months we want to add something else. Let's say, for example, a dog or something, right? So yeah, they are thinking that this is not the case. We should not do this way. And probably they are right. So they have, for every button we are adding, their code has dependency to that button as well. So for sure, let's see the class diagram. Yeah, so this animal voice service, you see, dependency to cat, dependency to dog, and if we add other things, then this dependency will increase. All right. So now they are thinking, is there any way that we can avoid this repeated thing that we are doing? So all of these repeated steps, right? The current code is this, right? So animal voice service, and these are those two print piece of the code that just print the voice of the animal. All right. So is there a way that we can prevent breaking the dry rule? What is dry rule? Don't repeat yourself. This is a very famous rule. Don't repeat yourself. And we are repeating ourselves, right? That's why they are, that's, what they bothering them, right? All right. So they propose a dreamy code. What is that dreamy code? They are thinking to pass only one thing here and never change the code anymore, right? They are thinking to this dreamy code. So is it possible we just create uh, one method and just pass something here, a class, a very generic class that it can handle every kind of animals even in the future, right? Cat, dog, horse, whatever. Yeah, we add the button. Yeah, they are thinking in this case, right? But you can imagine that this dreamy code is very similar to that, family name in the example that I took at the beginning of the lecture. So you remember one family name, and then everybody who has the same name, we can, send it to that meeting. Or we had one slot for all type of the coins. So now they are thinking to create one slot here to be able to pass any kind of animal. Is it possible? Yeah, that's the beauty of the object oriented, right? Okay, so if this is the case, then uh, here uh, we just need to uh, pass one animal here, let's say a cat or whatever, and this portion of the code needs to call the get voice of that animal. But how can we make sure that that animal that we are passing here has this get voice, right? So we are gonna create a code that shouldn't be changed anymore. So in other words, we want to create a piece of code and create a jar file and send it to the other company, which is our company actually. And uh, if we add any other animal, we can use the same jar, right? That's the beauty of uh, you know, the object oriented, as I said, right? Okay, so how can we, do that? How can we make sure that in the future if we created, currently we know that the dog and cat class has this get voice, but how about if we create a, let's say, a dog button, and we create a dog class, and then I'm sorry, dog is here like this, and how can we make sure that that dog class has this get voice? Somehow we should make sure about this, all right? And in other words, we need to have a template, template that force us that we need to have a get voice, and that what is it? That's the interface job. You remember that? So when we create an interface and when we create an abstract method, let's call it abstract method get voice, right? And the all of the animals from now on we create, they should uh, implement that method. So in that case, in that way, we are sure that all of the future animals that we are passing to this method, uh, you know, implements this get voice. All right. So let me go ahead and show you in the demo, right? All right. So let me summarize what I said here. So they will define an interface like this. So you see, this interface will be created by them, right? And this is a generic animal. It means that it is a template. It is an interface, right? It's a conceptual thing. And they will create this abstract method. And they are saying that, hey, guys, so I create the code based on the animal interface, not any specific, concrete class, right? So from now on, you are in charge to create the class by yourself, the animal class, but your animal class should have implemented this animal interface. All right. And if this is the case, I guarantee that my code works fine. They are guaranteeing, right? Okay. So in this case, if we do this, then the dependency moved from a concrete class cat, dog, and etc. to an interface. Yeah, this interface. Now, when a class is passed to this guy, this method, so let's say, for example, cat. If we pass a cat class or object here, what would happen? Then at runtime, Java will decide which get voice it should call. So because when they are creating a jar file for this guy, they don't know what we are going to pass to this animal, this parameter. But Java can decide at runtime that, it can recognize that, it's a cat, and then it calls the cat get voice. If we pass a dog, Java will recognize it and it calls the right method get voice. All right. And this is the beauty of the, polymorphism and the, object oriented that I was talking about. Okay, so now the question is, what should our company do up to this point? So their job is, obvious that they want to create an interface and they want to, uh, make the dependency of the code to an interface. But how about our part? So from now on, we are in charge for the cat class and the dog class. They are not, anymore, right? So they just create an interface. right? So we need to create a dog and cat class, and also if we want to, improve the code by other um, animals. All right. So uh, let's see, what is the our job to do in this case? If we, you know, just keep these classes like this, it's not gonna work, right? How come it's not gonna work? Because the dog class and cat class, uh, they should have some relationship, with the animal interface. So how can we make a relationship for the cat class with the animal interface? It should implement that interface. If this is the case, if they implement, then yeah, there is a relationship between this class and the animal interface, and then we are good. All right. So in our part, we need to implement animal here and implement animal here. And this would be the end of the episode 5. So here is the other changes that we need to know about. So the animal interface looks like this. It has one abstract method, get voice, and also their code, as we said, is changed to this guy. So this method is, from now on, it has dependency to the animal interface. From our side, uh, there won't be any changes, right? We can use the same code, right? The only thing that is changed is that from now on, we are in charge for these cat and dog classes, right? All right, so let me show you and make all of these, changes in the code before going further. Uh, to save some time, I applied some of those changes, but these new changes need to be, applied. So, first of all, we would need to create a new interface, and the interface name would be animal, right? The interface just have one public string get voice, one abstract method, all right? And we don't need, I mean, they don't need this cat and dog class. So let me just um, copy them in our code here, and we can remove them from here. Yeah. Okay, so what else we have here? Uh, yeah, yeah, they simplified their code. No cat anymore, so just animal interface. Let's call it A, right this. Okay, so from their side, everything is fine now. All right, as you can guess, we need to create another jar file. So we export as the jar, and everything fine here. Let's call it version 4. Yeah, and the rest of that is fine. Just all right. Okay, now we need to first to go to the build path and change our jar file to version 4. Okay, apply. All right. So our side, what else we need to do? Uh, Okay, so here, yeah, we need to remove this guy the easiest way. Animal voice service and control 1, import this guy, and the cat, we need to write cat, and dog is uh, recognized. So it is complaining that, uh, look at this complaint, that the method print voice animal in the type animal voice service is not applicable for the argument cat. Yeah. So I'm sure that you guys can figure it out what's the problem here. So this cat is not of the type of the animal right now. Okay. Let's go to the cat. So it is not an animal, and the same thing for the dog. So as we said, we need to implement the animal interface. In this way, we create an is a relationship between these two, and that's why we can, uh, you know, pass and use that method. Yeah, we can do the same thing for the cat. And now if you return back here, yeah, no complaint anymore. So we need a is a relationship, all right? Okay, okay, what's happening here? Uh, so here you know, we pass the cat to um, the animal voice service here, the animal, right? We pass the cat here. And then Java at runtime, it can recognize that this is a cat and it calls the cat's get voice, right? Since there is a relationship between the animal and the cat, and that's why we can do that, right? And this is called polymorphism. So we have a parent object here. We wrote our code based on the parent object, but at runtime, we can pass the child object. And this is called polymorphism. So I explain all of the material of this slide and I put it here for your reference. Okay, now let's define and define the polymorphism officially. From etymology point of view, what's the meaning of polymorphism? So having many forms or shapes, yeah, having different forms. You see, all of them has, this concept that polymorphism is something that, an object or something can have different forms or shapes or styles, right? And this is, what we need for our definition. So the ability of assigning or passing a child object to the parent's reference. Yeah, you remember that? So animal, we wrote the method based on the animal interface, and then at runtime, we passed the child object, the cat or dog, right? So in our examples, we use the passing parameters, right? But this is the same thing for assignment statement as well. So you can have, a, let's say, for example, list, which is an interface, is a parent, right? Let's say, for example, employee equal to, I'm sorry, let's say just a name and then new array list. right? Something like this. So this is the parent, and it's an interface, and we can assign a child object to it, right? So yeah, this is the beauty and the masterpiece of the object oriented, that we call it polymorphism. All right, from now on, if we add something new, a new button, then voice services company does not need to change anything. They are done. Even though they will lose money, but yeah, they are done, right? And but in our company, we need to create a new class, dog, and then it should implement animal. Every class that we are adding, it should implement animal. Otherwise, we cannot use their code. All right. And also, we need to add a portion for that um, for that particular animal in our application. So one class and one portion for the that animal. All right. So yeah, I will show you a demo, but before that, let's see. So this was our old code, and this was the dependency, right? And if we add, let's say, a dog, yeah, we would need to add another dependency like this. But right now, their code has dependency just to one interface. And this, you see how simple it is. To show you that we can use the same jar file and they don't need to change their code anymore, I am going to add a new uh, animal. Let's say we are gonna add a dock class or dock button. So we would need a dock class, all right? So let me copy and paste it here. So let's call it dock. And yeah, we just need to, yeah, it implements the animal. Uh, I don't know, maybe quark, something like this. Yeah, its name. All right. So what about the game? Yeah, we just need to add a new uh, method like this. So let's say that this method is going to handle the dock part. So dock and dock. Okay. So let me see. So doc implements, yeah, everything looks fine here. What is this? Oh, there's a doc video. All right. And you see, there is no complaint, and we can use the same code, the same jar file. We didn't touch the jar file. The only thing that we would need if we add a new class, that class needs to implement the animal interface. And that's it. There would be a is a relationship between the dog and animal, and that's enough for polymorphism. Let me give you some notes here. Um, if the parent is an interface, then the parent-child term is more appropriate. So we use the subclass and superclass when we have, both are classes. But if the parent is an interface, probably parent-child is a better way to call them. And also, this is an important point here that, in the examples, we had an interface to create a polymorphism relationship, right? So, but it is not the case. Instead of the interface, we might have a parent class, right? So if we have a parent class, then we can pass the child objects instead of the parent class. But interface is more popular. That's why I said when I was covering the interfaces, I say this is a very important thing. And you will hear a lot during the semester about the interfaces. Okay? So as long as there is an is a relationship, polymorphism is available, right? And we know that for inheritance and the implementation of an interface, both of them are is a relationship. And also, yeah, later we will talk a little bit more there are some subtle things that we need to mention, but we will cover that later. All right. So we are also almost done here, but before finishing that, I need to show you three things. First, yeah, let's get back to that vending machine again, right? So we have one slot for different coins, one interface for different coins, right? At runtime, when someone inserts a coin at runtime, this is a runtime, yeah, example, yeah, it will recognize what coin it was, right? Yeah, now I am asking you, isn't this an example of polymorphism, right? We have one slot, a parent slot, and the coins could be considered as the child, right? And how about the other examples we saw, right? Okay, so the family name, the parent name, if we have parent name here, then we can pass the child, right? All of the siblings can go in this meeting. Again, isn't this an example of polymorphism? Yeah. Okay, so at the end, I'm gonna summarize all of these four concepts that we have seen so far. Yeah, abstraction, what was that? The ability of separating the interface from implementation. Inheritance, that was a two-way ability. One way we extend a parent class capabilities and by creating a child class that gets all of those parents capabilities, and possibly they can define more. And the second ability in the inheritance is the other way around. It means that we have some similar children, and then we factor out all of the common thing inside a parent class, right? And what else? Uh, the polymorphism that we just finished, the ability of assigning or passing a child object to the parent's reference. And also we learned in encapsulation the ability of bundling attributes and behaviors and controlling their visibility. That's what I had for today. See you guys in the next lecture.